Hello everyone, so I think it's about time we got started. So for anyone who doesn't know me, my name is Callum Ryder. I've been Raytec with for 4.5 years now, but since then always involved on the hazardous area side of the business. So today we're looking at a webinar called Guide to Replacing Fluorescent EX Lighting with LED. Good to see some familiar names on the attendees list and also a few names there which are new to us, so welcome to everybody. So there'll be a section at the end for question answers. You should see a little question section in your pin, which you can use to ask questions, and then I'll keep an eye on those as we go through, but we'll leave some time at the end to go through any questions which you might have. So firstly, let's have a quick look through as to the agenda and what we're going to go through today. So we'll look at what you need to consider when upgrading from fluorescent to LED. We'll also look at the term retrofit and what it means, but also how different manufacturers use that term in different ways. We look at what a like-for-like replacement actually is and possibly challenge the general consensus by exploring how you can replace a 2x36 watt fluorescent with a smaller LED equivalent than you maybe thought. And we'll also look at emergency lighting options and discuss how you can improve the reliability and quality of your emergency systems. So before we go into that, I'll have a quick recap of the benefits of LED. Now, you may or may not have read our white paper, LED versus fluorescent, which we produced a couple of years ago now. But this slide is just a quick recap of what we found in there. That white paper is still available to download from our website. We'll share these slides after, so you can use the link there. But you can download this and look at a full summary of a full analysis of the comparison. But just to do a quick recap. So we found that upgrading from fluorescent to LED will provide less degradation. In terms of the luminaires, will provide better output and for a longer period of time. And because LEDs have a significantly longer lifetime, and the number of maintenance interventions are significantly reduced, and that can result in big cost savings. That's a big part of this presentation. As we go through, we'll see how important maintenance is. Performing better in extreme temperatures, so they're more suitable to harsh environments, and that means LED luminaires perform better in extreme cold, but also very hot temperatures. And also the nature of the design of LEDs makes them more naturally durable and more resistant to vibration, which in the context of hazardous area applications can be very important. Better control of light. So the directional nature of LEDs means that the light is targeted exactly where it's needed, so less light is wasted, which means there's less light pollution. And also more reliable emergency solutions. So all the points we've covered in this slide are all magnified under emergency conditions, because generally a luminaire will operate at a smaller percentage of its output in emergency mode. So things like as the temperatures increase or decrease, and that fluctuates the performance, again, that's going to be heightened and multiplied the severity of that in an emergency situation. And so LEDs overcome many of these problems which might be associated with traditional fluorescent lightings. But if you're attending this webinar, then there's a good chance you already understand these benefits and the reasons why LED is superior. So the idea of this presentation, this webinar, is to look at some more practical considerations that you need to take into account in order to select the right luminaire when upgrading to LED. So fluorescent lighting is used extensively across the world, a wide range of applications, and that's certainly true in the hazardous area environment. And that means because there's so many fluorescent luminaires installed, that the retrofit market or the upgrade market to LEDs is a huge market. But what exactly do we mean by the term retrofit? So in truth, the term retrofit is used differently by different manufacturers. So we're going to start by taking a look at that. So option A, which you can hopefully see on the screen there, fitting LEDs inside an existing GRP or glass reinforced plastic fluorescent body. So because fluorescents are so popular and used so extensively across the world in hazardous area applications, existing manufacturers who possibly supplied these fluorescents originally obviously want to capitalise on the upgrade market or the retrofit market as the benefits of LEDs are recognised and become more of a desire for customers or end users to change. So in order to do this, they offer LED kits which can fit inside the existing housing, the existing GRP housing. Works differently with different manufacturers. Some can just replace the tubes with the LED kits, some have to replace the control gear, but the general idea is that you use the same housing and fit an LED kit inside that to convert your existing fluorescent to an LED luminaire. Or there's option B. So these are replacement fittings, so entirely new luminaires which have the same dimensions, fixing centres and cable entries as the traditional fluorescents which they are replacing. So this is the camp where Raytec sit. So all our luminaires are retrofit, but they're designed to replace the existing luminaires, not to fit something inside the existing housing. So the argument for option A is that it's a quick, low-cost fix. We're going to look at this a little bit more detail to see if that's actually true. But regardless of that fact, fundamentally we say that option A is wrong in terms of the method of grading. So why is that? Why do we say it's fundamentally wrong? And the main reason for that comes down to thermal management. So we know the benefits of LED, we know the advantages it can give you to your installation, to your existing lighting, but the benefits of LED are only achieved when it's paired with an efficient thermal management system. So this, without that, with the thermal management system, it means that lifetime is better, but without it, it means the degradation will increase, lifetime will be decreased, and the likelihood of failure will also go up. So they're all traits that you would commonly associate with a fluorescent rather than LED. And that's mainly because the heat is trapped within the luminaire. So if you're using a GRP housing, GRP is a very poor conductor of heat, and that heat is all trapped within the luminaire to cause the LEDs to get hotter. So it's sort of the shorter life, high degradation, less reliability. In contrast to a bespoke LED fitting, which uses proper thermal management, give you that cooler LEDs, longer life, lower degradation, and more reliability. So in essence, what we're trying to say here is why would you upgrade to LED in the first place if you not take advantage of all the benefits which LED has to offer? And to do that, an efficient thermal management system is critical. So looking back at the two options again, so with that knowledge and the understanding of how important thermal management is, knowing that GRP and the GRP housing is a very poor conductor of heat, we can say that option A is a poor LED retrofit in terms of the performance it gives and the lifetime it gives you. And then we also have the option B, which we can say is a good retrofit, providing the LED luminaire uses proper thermal management. So yes, option A does provide a quick fix, but really that's all it is. I'm sure many of you will know from experience that a quick fix isn't necessarily the right fix. And plus, in reality, just looking a little bit more detail, option A and considering whether it is actually a quick fix or not. These solutions might not be as easy to fit as you might think. It'll depend on the manufacturer and the system they use. As I mentioned, touched upon earlier, different manufacturers have different systems and different ways which these LED kits are installed. But in some instances, it'll actually be quicker to remove the fitting and entirely replace it with a bespoke LED retrofit, which has those same dimensions and cable entries and so on, which we're going to look at in a little bit more detail over the next couple of slides. And as well as that, it might not be as cost effective as you'd think either. So the cost of these replacement kits can sometimes be as much as the replacement luminaire itself. So if it's not saving you a huge amount of time, it's not saving you a huge amount of cost, the obvious decision would be good for something around option B, which we can see is a better performing LED retrofit. So looking at now some of the practical examples, looking at option B in a little bit more detail. So to be classed as a retrofit, the new luminaire should have the same dimensions, the same cable entries and fixing centres as a traditional fluorescent. So because the retrofit market is so big and there's so many luminaires to take down and replace, the ease of installation is key to this. So the dimensions are important because it means the same cabling can be used. If you have a luminaire which is the same physical size, it means the cables can travel the same distance between luminaires, and that's really important for ease of installation and being able to use the same existing cables to keep that installation cost to a minimum. That's also similar with the fixing centres. So having the same fixing centres will mean the same bracketry can be used. So rather than having to especially if a large installation. Adding bracketry to that could significantly increase cost of the installation. So having fixing centres in the same location, the same profile, the same depth, the same size means that the existing bracketry can be used when installing the new LED luminaire. And then lastly, cable entries. So the new luminaire, LED luminaire, should have cable entries in the same location again, so the cables can enter in the same location, so the same cable glands can be used. And again, so that helps to reduce the cost of installation and make it easier as a plug and play replacement solution. So if you combine all these elements together, that's exactly what you get. You get a plug and play replacement, which will help reduce the time and the cost of installation compared to a product which hasn't been designed with these features in mind. So we can say that a product which has all these features together provides you a true retrofit solution. So defining what a like-for-like replacement is. So a question which maybe the first question you asked, that will upgrading to LEDs, so will swapping out a 4-foot fluorescent linear with a 4-foot LED linear, will that reduce your operating costs? So the answer is yes, it will reduce energy costs. But the energy savings themselves for like-for-like replacements are likely to be minimal. We'll look at a table in a second which compares this, but the biggest savings are going to be on maintenance. So because of the benefits of the long lifetime, because of the reduced maintenance interventions which will be required, the main operating cost reductions will come from reduced maintenance. Again, this is something we're going to look at in a bit more detail. We're going to look at some installation examples, work out how the costs work out. But the main saving in terms of lifetime of the unit will be through maintenance rather than energy. So this table just shows you that comparison. So 2 by 36 watt fluorescent typically will be around 72 watts, and using the LED equivalent as Raytec Spartan WL168 luminaire, the consumption of around 68 watts. So there is a small saving there, but no great energy savings in terms of money in the pocket or costs, noticeable cost difference. And you see also there a similar lumen output, but critically the difference between these two is that the fluorescent is measured at source, whereas the Spartan unit is a lumen figure, which is delivered lumens. And we're going to touch on this a little bit later when we look at some statistical data. And the reason for these comparisons is dramatic, as you might expect after swapping out a sodium floodlight with a LED floodlight, for example. That's mainly because fluorescent is more efficient than some of these older technologies. But again, it comes back to the point where the main savings and the main operation reduction costs are going to come from maintenance. So anybody who has read our white paper, which I touched upon earlier, LED versus fluorescent, these next few slides might look familiar to you, but just to recap. So what we did is we did a typical installation looking at 20 luminaires. So that's an installation of 20 fluorescent luminaires compared with the 20 equivalent Spartan linear luminaires. We measured performance using lumen output of the total installation and how it varied across different temperature ratings. We also factored in, critically, we factored in the effects of degradation and also maintenance, and which obviously we know over the lifetime is going to have an effect on the total lumen output of the installation. So this is just a quick summary of the data we used. Like I say, this was covered in our white paper in more detail, so if you want to refer to that after this webinar, you can see a full breakdown of how we reached this data, how we came to our conclusions. But let's just look at performance initially. So this is out of the box, brand new luminaires. So the first two lines you can see on the graph are representing the LED luminaires. So this is Spartan WL84 and Spartan WL168. So these two luminaires, the WL84 will traditionally replace a 2 by 18 watt fluorescent in terms of the size and dimensions of it, and the WL168 will traditionally replace a 2 by 36 watt fluorescent again in terms of the size and dimensions. Let's have a look at how that actually equates to performance in total number of lumens across the installation. We'll overload the fluorescence on top of that. And what's surprising, that given the similar spec of the two technologies that we looked at on the table previously, just how much better the performance is of the LED units. So why is this? So fluorescence lumen figure generally is measured at source, which I mentioned earlier. So a significant proportion of this figure is lost due to inefficiencies or because the light isn't being directly where it's needed. But in contrast, the lumen figure on the Spartan LED fitting is delivered. So we know that 100% of that figure, that 6,800 figure, is going to be delivered on scene. So looking a little bit more detail at the graph. Interestingly, because the gap is so significant in very hot or cold temperatures, that the dual 84 LED fitting is actually outperforming the larger 2x36 watt. So in terms of the size, it's half the size of what you would traditionally replace a fluorescent with. But we can actually see that across most temperatures, other than the optimum range of the fluorescent, which is between 0 and 30 degrees, is that the dual 84 unit is actually outperforming that. So let's keep an eye on this as time progresses and we move to 8,000 hours. So that's around 1 year of the units being installed. So just after a year, the 2-foot LEDs now outperform the 2x36 watt fluorescents in all but a very small temperature range. So the lines of the graph has moved down on the fluorescents because of the higher rate of degradation. So they degrade at a significantly faster rate than LEDs, and that performance advantage in terms of the optimum temperatures is narrowed really significantly. Then moving on for the 3 or 4 months, now at 12,000 hours, so just under 80 months of operation, we can see that the dual 84 unit is now outperforming that 2x36 watt fluorescent in all temperature ratings across the board. So what does this tell us? So it tells us that LEDs are much better at handling extreme temperatures, so whether that be extreme hot or extreme cold. You saw by the shape of the graph that fluorescence fluctuates significantly depending on the temperature, whereas LEDs do not. And because of that difference and that significant gap in the performance, a 2-foot LED luminaire can actually outperform a 4-foot fluorescent or a 2x36 watt fluorescent. And that is from new if the temperatures are below freezing or above around 27 degrees, or if looking after 12,000 hours or just under 18 months, that unit is going to outperform the larger 2x36 watt fluorescent in all temperature conditions. So with that understanding, the question might be asking is, should you therefore be replacing a 4-foot fluorescent or a 2x36 watt with a 2-foot LED instead, rather than what you might commonly be used to doing is replacing with a 4-foot LED. So for new installations, absolutely. There's absolutely no reason why you wouldn't do that, because there's no existing infrastructure to take into account. We know that a 2-foot LED will provide equivalent performance or superior performance, especially as the fluorescent units begin to degrade. But for existing installations where you have existing fluorescents installed, there's still a question mark over that, because you still have considerations of new cable, new brackets, new glands, which all adds to the expense. So in terms of the feasibility of this, we have to say that replacing a 2-foot LED instead of a 2x36 watt fluorescent in the traditional sense isn't feasible, but we do have another solution. So if you're familiar with Raytec products, you may have seen this unit before, but just to introduce you to this unit, so this is the dual 84-1200. So what this unit is effectively is it has the power of a 2-foot LED luminaire, but it is enclosed in a longer body to give you that benefit of the ease of installation. So it provides the ideal solution. So it's sort of the best of both worlds for customers who want to replace a 2x36 watt but want to retain that existing infrastructure of brackets and cabling. So it means that the lower consumption is going to mean that energy costs are halved while maintaining light-for-light performance from that existing fluorescent installation. And the fact it's got the same dimensions as the 2x36 watt fluorescent units means that those going to reduce the overall capital outlay and make installation much quicker and much easier. So now let's look at a typical application and see what effect this has in real terms. So using an application size of 200 units now, So using a WL84-1200 instead of a 2x36 watt fluorescent will actually provide you a 38 watt saving per unit. So the 72 watts of the fluorescent minus the 34 watts of the new LED fitting gives you a 38 watt saving. And then over installation of 200 units, that's going to give you a 7.6 kilowatts per hour saving. So in terms of monetary value of this, that's going to equate to around £1 a minute, or over the duration of a year, over £1,000 a year for the duration of the for the total installation. Sorry. Now, obviously, that figure is going to be multiplied for bigger sites. 200 units is a fairly modest size. If you go into an offshore rig or for refineries or bigger applications, that the number of units is going to be multiplied, and that saving is also going to be multiplied. But as well as actually monetary savings in terms of energy, there's also the fact that the usage is halved. So lots of application has this area environment rely on use of generators, such as offshore. Anything offshore tends to use generators, and by upgrading lighting to a unit which can save half the usage will mean that 50% of that is reduced, obviously, which means that that remaining 50% can be used on other equipment for generator capacity. So it frees up generator capacity effectively. And generally upgrading your lighting to LED and to this WL84-1200 units lighting is significantly cheaper than upgrading your entire generator system. However, the greatest cost, as I mentioned earlier, is still going to come from the reduction in maintenance. So all these savings, the usage savings, the energy cost savings, great to have. It's nice to be able to reduce that, but the key saving is going to come from maintenance. So we know that because the lifetime of the luminaire is longer, up to 100,000 hours for an LED unit, with no need for relamping. A fluorescent luminaire may need to be relamped every 12,000 hours or so. This may involve specialist equipment. Access may be difficult, especially for hazardous area applications where access quite often is difficult. And it'll definitely cost more time and resource to be able to do that. So a simple change of your lighting is going to have a huge impact in terms of the long-term savings of maintenance and through resource and time, which can be saved through the upgrade to LED. So now I want to go on and look at emergency performance. So another advantage of upgrading to LED is the boost in emergency performance and providing a more reliable emergency solution. So let's look at why LED is more reliable. So there's a few factors to look at here, but we'll run through each. So firstly, maintains output over the backup period. So what we mean by here is that the output of the LED luminaire traditionally over a 3-hour period will remain constant. We know that because it's consistent in terms of the output it gives. There's no, as after 3 hours the output won't have dropped, but in contrast, fluorescent, this is a common fault with fluorescents, that over the duration of the output period, or the emergency period, sorry, that this output level will drop slightly as the battery depletes. Less degradation of components. So LED luminaires rely on fewer components in comparison to fluorescents, which in contrast have starters and ballasts, and these components commonly degrade. And this could result in a failure when trying to switch to lower power. And obviously in an emergency scenario, that's the last thing you want to do, is to find out that the component in your luminaire has failed and it's unable to switch to, or unable to provide emergency backup power. So by simplifying the solution with an LED, LED luminaire makes that safer, more reliable for when switching between normal mode and emergency mode. Consistency in harsh temperatures. As we know from the study that we've just looked at, that LED performance does not fluctuate in extreme temperatures. Output level remains constant. That's exactly the same in backup periods. In contrast, we know that the effect which extreme temperatures have or cause to fluorescent luminaires cause output to drop in extreme temperatures, and this problem is magnified in emergency conditions because the unit is operating at a small percentage of its original output. So these fluctuations could be quite dangerous. It could lead to the output in emergency being virtually non-existent if the temperature is having that effect on the luminaire. And lastly, Raytec Spartan emergency products can also offer up to 100% light output in emergency. And that could be really important for certain applications like evacuation areas or lifeboats, say, where maximum light output is needed for a short period of time. So that's something which can be traded off with duration, but we can offer up to 100% light output in emergency mode. And then also just a small point which I haven't covered on either of these 4 icons, but naturally LED luminaires also have redundancy built in. They rely on a greater number of light sources than a fluorescent does. So a fluorescent luminaire will traditionally have 1 or 2 fluorescent tubes. If 1 or 2 of these was to go, obviously that causes a large proportion or all of the luminaire to fail. Whereas in contrast, an LED relies on a much greater number of light sources. So the WL84 luminaire, which we looked at, as well as WL168 luminaire, have 84 and 160 LEDs respectively. If in the unlikely event there was to be failures to these, then output is still going to be maintained by the existing range of other LEDs, which tend to be split up and banks provide power in that way. So having that redundancy gives you a lot more reliability and safety in your emergency solution. Modern LED fittings are also now emerging, which build in more automation into the testing procedures, which are required as part of the hazardous area certification. Again, if you're familiar with Raytec products, you may have seen that we recently launched our own intelligent emergency system. And this uses an inbuilt microprocessor which automates these testing procedures. Batteries are cycled automatically, whether that's for commissioning. So the batteries are depleted and recharged 3 times automatically prior to full installation. Also undergoes battery health checks, so different kinds, so daily, weekly and monthly different battery health checks. And the status of the luminaire is constantly communicated via an LED health indicator, which you can see by the different colour lights on the slide there. Each has a different meaning and will tell the user a different message as to how that luminaire is performing. If you quickly look at the key features which are listed in icons on the right hand side, it's just something else to consider also in the choice of intelligent emergency systems. Are really features that should be really important criteria of the emergency luminaire which you select. So it should have random testing. Obviously, if you have a large number of luminaires installed, you don't want all those luminaires to be entering a testing cycle at the same time. So to have random testing which does this at different times is really important. They should be able to hold reserve capacity during testing. So if a luminaire is undergoing a testing procedure and was to switch to an emergency scenario during that testing procedure, that luminaire should always still have some reserve capacity, no matter what stage of the test which the luminaire is going through. And that will always ensure that it will at least provide some level of output, or at least some duration, I should say, of output should it switch to an emergency mode. And lastly, 100% output during testing procedures. So when a luminaire is going through testing procedure, the last thing you want to see is to drop to a fraction of its output. You want it to be able to carry on as normal and provide the same light output as it would do in non-emergency mode. So 100% output during testing is another really important factor. So they're the features of an intelligent emergency system, but what does that actually mean in real terms? So it means there's less reliance on human intervention, because this is building in automation. These tests are happening automatically. It means that maintenance isn't going to be missed. There's less opportunity for error or inadvertent neglect, and that in itself makes the system more reliable. It makes maintenance easier, quicker, and less costly. You're not relying on resource to go out and physically test the luminaires. It happens automatically. It means that the testing procedures won't be missed, and it also means that it's easier and quicker to identify those which are undergoing a test procedure, and it gives you that peace of mind as well to know that the luminaires automatically have that built in. And that's what those tests are automatically going to be carried out and communicated the status via the indicator. And because of the nature again of hazardous area applications, being able to do this remotely and being able to view an LED health indicator rather than having to physically test the luminaires provides greater safety. It avoids the need to have to access the luminaires up close and have to do any in-depth maintenance work, so it makes the actual procedure safer. And all these elements together combined provide a more reliable emergency system. By having a system which is more reliable, it makes the environment safer, which is obviously the key idea behind an emergency luminaire in the first place. So all these factors, these features, and the benefits it gives ultimately makes the environment safer. So quickly, just to summarise what we've been through. So we've discussed how important it is to use the right retrofit solution, i.e. a bespoke LED fitting rather than fitting LEDs inside an existing housing. We discussed the issues which fitting LEDs inside an existing housing has, and how the option B, which is the replacement LED luminaire with proper thermal management, provides the best performance and the best reliability. We've discussed how important it is to select a replacement fitting which has the same dimensions, the same cable entries, and the same fixing entries, the same fixing centres, to make installation quicker and ultimately less costly. So we reduce those costs during the installation process, being able to use that existing infrastructure already on site. We've looked at the performance of LED versus fluorescent, and we've identified how you can replace existing fluorescents with a lower power LED fitting than you perhaps thought you could, and that delivers greater cost savings. That was when we looked at the different graphs and the greater performance advantage than you maybe would have expected from LED when compared to fluorescent, given the similar spec in terms of the data sheets. And we've also identified specialist fittings such as the AA84 1200, which allows users to benefit from the best of both worlds. You still get that greater reduction in costs from reduced energy savings, from reducing their reliance on generators, but it still gives them the benefits of an easy installation, which can be achieved through a true retrofit solution. And finally, just to recap on the solutions which Raytec offer. So again, some of you may be familiar with Raytec, but for those who aren't, so the traditional retrofit solutions, the AA84 and AA1608, which we looked at earlier in the presentation. So the AA84 would traditionally replace a 2x18 watt retrofit in terms of the size and dimensions. The AA168 would traditionally replace a 2x36 watt, again in terms of the size and dimensions, but we looked at how the performance works and how that can allow us to use specialist fittings such as the AA84 1200, which has the power of a 2-foot LED luminaire, but with the same dimensions and considerations for a 2x36 watt fluorescent. Then we also do other products such as the AA168 1500. There are some 2x58 watts products installed in the field, also known as 5-foot, which again is effectively this unit is effectively a 4-foot AA168 with a slightly extended body, again to allow you to use those retrofit solutions in terms of using the same cables and the same glands and fit in bracketry. All our units are available as Zone 1, which are the images you can see here. They're all Zone 1 products. We also offer them all as Zone 2 variants and also as an industrial variant as well. And they're all available as emergency also. Then just a final note, so obviously this presentation, this webinar has all been focused on linear luminaires and replacing existing fluorescents, but we've also done this research and looked at this data for all other types of luminaires as well, which cover our full range. So floodlights, high bays. So the shot you can actually see on the screen here is our LED upgrade guide. It guides you on the unit which you're looking to replace and what the equivalent LED luminaire should be, and takes into account all the gear losses, delivered lumens at source, that sort of thing. So it's really quite a useful tool. So you can download this from our website. But if any other questions on this or anything that comes to mind, you can of course drop us an email, drop myself an email, any of the team will be happy to help.